Today we are going to talk about the IUPAC naming of organic compound. There is several rules to name different organic compound. Today we are going to focus on the rules and also we will discuss the examples. For the first rule, we need to find the longest carbon chain, including all functional groups. The second rule is that we need to name the substituents and indicate their positions. The third rule is if there are two or more of the same substituent are present, we need to name them with multiplying prefix such as di or tri. For the fourth rule, we need to number the carbon which based on the functional group priority. Here is the IUPAC priority list of functional groups. How can we use this list to name different organic compounds? For example, we have such compound. We have a compound with a hydroxyl group and also CC double bond, which is indicated that it is an alkene. Then we need to base on this list to name this compound. Since alcohol has a higher priority than alkene, therefore we need to name alcohol first before we name alkene. So the naming sequence is 1, 2, 3, 4, 5 in this direction. Actually, for this priority list, the more polar of the bond, the higher priority of the functional group is. The next rule is that we need to number the carbon which the sum of the substituents is the smallest. And finally, the last rule is that we need to arrange the substituents in alphabetic order in the naming. Here is the example. The first thing we need to do is to recognize the longest chain of the carbon atom. The longest chain will be something like this one. And afterwards, we need to number the carbon atoms. So we can number it like that. And also, we can number it like that. So we have two numbering system. But the common thing is that we have 7 carbon atom involved in the longest chain. That means it is a heptane. Okay. The second thing we need to do is to identify the substituents. So here is a substituent ethyl group and also methyl group. To determine which numbering system is correct, we need to base on the substituent. If we are based on the upper numbering system, we have 4 ethyl and 5 methyl. If we, according to the lower part of the numbering system, we will have also the same for ethyl, but this time we have 3 methyl. So we need to choose the smallest number of the sum of the substituents number. So the smallest sum is this one, because 3 plus 4 is equal to 7 and 4 plus 5 equal to 9. So the 7 is the correct numbering system. So the name of this compound will be 4 ethyl 3 methyl heptane. Okay, in this compound, we have a carboxyl group over there, and according to the functional group priority list, we always number the carboxyl group first. So here is 1, 2, 3, 4, 5, and then we have 3 chloro substituent. In this case, we will have the name because we have 5 compound, it is the longest chain of the carbon atom, so it is actually is a pentane, and it is a carboxylic acid, so it is a pentanoic acid. And afterwards, we need to name the substituent. Since we have 3, the 3 substituents are also the same as the chloral substituents at the 4 and 5 position. So we have a chloral substituent, and since we have 3, so we need to indicate trichloral. So in this naming, we will have 4, 5, 5 trichloral pentanoic acids. And in this compound, the longest carbon chain which involve all the functional group is this one. So, and since the hydroxyl group has a higher priority than the halide, so we will name the hydroxyl group first. 1, 2, 3, 4, 5, 6, 7. So it is actually as a heptane 2, 4 diol. And one more reminder is that when we add when we have a diol over there, we need to add a E over here. So, and afterward, we name the other substituent. We have a chloral substituent and also the propyl substituent. And we will name the chloral first according to alphabetic order. So we have 6 chloral and 5 propyl. So the name of this compound is 6-chloral 5-propyl heptane 2,4-diol. In this compound, there are 3 triple bond and other substituent, and the longest carbon chain will be like this, and it involves 6 carbon, so it is a hex, starting with a hex, and we have 1, 2, 3, 4, 5, 6 carbon, and the double bond position will be 1, 3, 5. So 1, 3, 5 tri-in. Okay. If it is a tri-in, we will add a over there. Actually, it's same as di-in. If we have a di-in, we'll also add a over there. And afterwards, we will name the other substituent. We have a ethyl and also idol, and we will name the ethyl first because according to the alphabetic order. So we have 2,4-diethyl and 3-idol. So the name of this compound will be 2,4-diethyl 3-idol hexa 1,3,5 tri-in. Here comes to the last example we are going to discuss. In this example, it seems very complicated, but actually it is not so difficult. As our usual practice, we need to recognize the longest carbon chain first. So for the longest carbon chain will be like this one, which involve all the functional group, right? So according to the functional group priority list, we will name or number the hydroxyl group first. So for the numbering system will be like this. And afterwards, okay, we have 2 hydroxyl group and also 2 double bond and 8 carbon. It is a octene, right? So we have 2 double bond in the position of 5 and 7. So octa 5, 7 di-in. And we have 2 hydroxyl group in the position of 2 and 3. So 2, 3 diol. Because we have di over there, we need to add a E. Because we have a di-in over there, we will have a. So, and afterward, we will enable the other substituents like chloral, idol, and ethyl. According to the alphabetic order, we will name the chloral substituent first. For the chloral substituent, we have 2 and in the position of 6 and 8. So, the name will be 6, 8 because we have 2, so dichloral. And we will name the ethyl group. The ethyl group will be in the 4 position, so 4-ethyl. And comes to the end, we have an idol, right? Idol substituent, and in the 7th position, so 7-idol. So for the name of this compound will be 6 8 dichloro 4 ethyl 7 idol octa 5 7 into 3 diol. So I hope you understand what we have discussed today. If you have any question, please tell me in the comment. And also I would like to give you some exercise for you, and the answer will be listed in the description area. So please enjoy chemistry, and because I do love organic chemistry. So I hope you enjoy this video.